Welcome to Daniel Maths once again, Daniel Maths Academy. From Wednesday JAMB Maths series with Daniel. In today's lesson, we'll be looking at solving more problems related to application of differentiation, and also look at coordinate and line geometry. If you're just joining us and you've not subscribed yet to our channel, do so to hit the subscription button and turn on your notification bell so you can get more amazing videos that are dropping on a daily basis. All right, and then with that all of our way, let's get started. So let's look at question number one. All right, now question number one here says that which the distance traveled by a particle from a fixed point is given as s is equals to t cubed minus t squared minus t plus 5 centimeter. Find the minimum distance that the particle can cover from the fixed point. So what we're going to do from this in this question is, first of all, that we need to rewrite this, and then s is equal to t cubed minus t squared minus t plus 5. So we need to first of all find the derivative of this distance. Okay, so this is going to give us ds over dt. We're going to differentiate s raised to t, and when we do that, this is going to give us, so this is going to become 3 times t, and then 3 minus 1 is 2. The minus, this is going to be 2 times t, and 2 minus 1, which is 1. Okay, and here we're going to have minus 1. This is constant, so this will be plus 0. All right, so this is the direct differentiation of this equation. Now, having this, we are now going to see if we need to find the minimum distance. Then we are going to of course equate this particle, this distance now, all right, to 0. So the velocity, remember that the velocity of equation starts at the point 0. So the s dt gives us the velocity, so we're going to equate this to 0 and solve for the values of t, right? So doing that, this is now going to become 3t squared minus 2t minus 1 is equal to 0. So if we do this using if you solve this quadratic equation using either completing the square method or factorization method, we're going to get that. So this is 3 and this is minus 1. So if I do that here, what I'm going to get is that I'm going to get minus 3. Well, two values of minus 3. So this is, let's say, 1 and 3. All right, so we have a minus 1. We're going to have 1 here. So the values therefore is going to become 3t square. All right, so we're going to have plus t, or plus, we're going to have, okay, 3t square minus 2t minus 3t. All right, and then we're going to have, this is going to become plus 1 plus t, and then we'll have minus 1. Look at this, that minus 3t plus 2t will give us minus 2t. Okay, then so you can see that we multiply that to get back that. So we're going to go, this is going to be 3t square minus 3t, then plus t minus 1 equal to 0. So factorize this, so this is going to become 3 into so this is going to become 3t. So factorize this, and we're going to get, so what is common next? 3t, and then it's going to become t minus 1, and plus this is going to be 1 invisible 1. We'll have t minus 1 equal to 0. So now if we take this up, we'll discover that we're going to get 3t plus 1 as factors. Take up the coefficients, and then the bracket is going to be what? T minus 1, and it is equal to 0, right? So having looked at this, we can now see that equating this to 0, and then we can now find the minimum point, which is going to give us, so here we're going to have that we say, so here we're going to say 3t plus 1 is equal to 0. This means that 3t is equals to minus 1, and t is equals to minus 1 over 3. For the second equation, we're going to get that t minus 1 is equals to 0, therefore t is equals to 1. So the value of t that gives us the minimum point is going to be the positive value, all right, which is 1. Okay, so you see that, so not this, because this is giving us negative sign, so we're going to substitute that value. All right, so we're going to take that value in to solve. All right, so here we see that we're going to substitute, right? t equals to 1. So we're going to take the positive values of t where we can see. So this is what we're going to take. All right, so we're taking this value. All right, so use that. So we're going to substitute the value of t. So at t is equals to 1, we're going to substitute this equation into this equation. So we're going to have t raised to the power 3 minus t squared minus t plus 5. So let's go. This is going to give us 1 cube minus 1 square minus 1 plus 5. Alright, so if we go ahead, this is going to give us 1 minus 1, alright, and then minus 1 plus 5. Therefore, we're going to get that this is going to give us finally 4. Alright, so this is going to give us 4. Now, the value, so this is going to give us 4, take note of that. So therefore the value, all right, the minimum distance that will be covered is going to be option B, which is 4.0 centimeter. This is the solution. Remember, first of all, you're going to differentiate this with respect to t to get the to form a quadratic equation. Like quadratic equation will exist at the point where the minimum velocity, the point for minimum velocity is going to be 0, all right, for a motion to occur. So we're going to equate that quadratic equation we now have to give us 0, and we solve for two values of t. Take the positive value that's going to give you the minimum distance, rather than ignore the negative value. So that with that we'll have 4 as our answer. Let's move on to the next question. Now here the next question says, if y is equals to x sine x, find the y over the x. Now x sine x, we're going to solve this question, very simple question. We're going to solve this using what we call the product rule. So we're going to call the product rule. Now what does the product rule states? Product rule states that if you're giving u, if y, so if y is equals to uv, all right, now therefore now we're going to differentiate to dy over dx, that's product, is going to give you u dv, u differentiate, all right, u dv over dx plus v du, and then over dx. Now this is the product rule. Okay, take u, differentiate v with respect to right hand u. First of all, differentiate v with respect to x, plus right hand v and differentiate u all with respect to x. So if we take that in mind, then we're going to say that, if we have that in mind, we're going to say u is equal, so having that in mind, u is equal to x, and you can say that v is equal to sine x. All right, so if we put that in perspective, now let us find, from this, let us find du over dx. If we differentiate u with respect to x, we're going to get 1, and from here, if you differentiate v, so dv with respect to dx, that's going to give us, differentiate sine, you get cos x. So this is going to give us cos x, right? Now, so we've gotten du, we've gotten du dx, we've gotten dv dx, and we've gotten u and v. So let's plug this into this equation, which is our standing formula. So this is our standing formula for product rule. Okay, now so I'm going to plug this into this and then express that. So what do I have if I do that? What am I going to get? So let's go ahead. So therefore have that dy over dx is going to give us u is x times our du v dx is equal to cos x, now plus our v is what, sine x, and times our du dx is equals to 1. So if I go further, this is going to give me x cos x plus 1 times sine x is going to be sine x. So dy over dx is equals to this. Now let's look for the option that is correct. X cos x plus sine x. X cos x plus sine x. Okay, so we can look at that as this. All right, so it is written in the second form. Remember that we can't see that here. All right, so we can write it. So this can also be written. Take note. So this is option B. Option B. Okay, so you can see that sine x plus x cos x. So this is the answer to this question. Now remember to pause the video and then have a replay. All right. If you have any question, you can drop your question right on the comment section and we'll answer your question. All right, let's look at the next question. Now, don't forget this is Wednesday, Daniel JAMB Maths with Daniel Maths Academy. Like our videos, subscribe and share to people that this video needs to get to. Let's go to the next question. Question number 3. Now, we are given that 3. So this question says that 3s is equal to 3t squared. So let's have this over here. S is equals to 3t squared plus 5t minus 10. And this is the displacement of a particle in meters. Calculate the initial velocity. Now, to get initial velocity, don't forget this equation is equation of distance. All right, distance is given as this. Now, let's recall that velocity is equal to the derivative to the s over dt. So that is how we get what the velocity of the equation. So let's differentiate this. So if we differentiate this with respect to t, what we're going to get is that we're going to get 60 plus 5. 60 plus 5. So this is what we're going to get. Now the initial velocity will be gotten when v is equal to 0. So this will be gotten when v is equal to 0. So this one will have our initial velocity. Okay, so now if we plug that in to have that 60 plus 5 will be equal to what, to 0, right? So now at that point, so initial velocity, sorry, will be gotten when t is equal to 0. Please, okay, take note of that. When t is equal to 0, initial velocity will be gotten when t is equal to 0. When t, okay, is equal to 0, that's initial velocity. So we're going to substitute v t equal to 0. So substitute t is equal to 0 into v is equal to 60 plus 5. So this goes ahead to give us that v is equal to 6 bracket 0 plus 5. So this is going to give us that v is going to give us 5 meter per second. So the correct option to that question is option C. So this is how we derive the equation. All right, or that's how we can calculate the velocity, initial velocity of an expression. Okay, now just to give you a pictorial form of this, pictorial form. So with this, so just a pictorial form of this, what we'll have is this will have a linear graph. All right, so we have this. So remember that at this point, that this is v, that this is your s. All right, remember these are s in meters and this is our t in seconds. At this point we have a 0, so this is the origin of this. Now at time 0, of course, when anything has happened, then that's we're going to have an initial velocity until the object begins to start moving. Same thing if this is also in velocity, meter per second, and also time. So the minimum velocity starts at when time is equal to 0 and it begins to increase and the velocity line and this corresponding increase on the time axis. All right, so this is what we have. Let's quickly go on to the next question. Now in the next question, we are asked to find the gradient of a line which is perpendicular to the line with the equation 3x plus 2y plus 1 is equal to 0. So we have that the equation is 3x plus 2y plus 1 is equal to 0. First of all, we need to write this in the form of an equation which says that the standard form for equation says that y is equals to mx plus c. So we need to write this equation into this form. By doing that, we're going to have universe 2y, all right, is going to give us is equal to this moves over becomes minus 3x and this moves over becomes minus 1. So you see what happened? 2y is here, 3x move over here become minus 3x, and then 1 plus 1 moves over becomes minus 1. So we can see from here that y divided both sides by 2, y is going to give us minus 3x minus 1 divided by 2, which can also be written as y is equals to minus 3x over 2 and minus 1 over 2. If we single this out, you can see here that y is equal to minus 3 over 2x, can be written this, and then minus 1 over 2. So therefore, comparing this with this, we have that our m is equals to minus 3 over 2, and then our c is equals to minus 1. So with this, so c is equals to minus 1 over 2. Now with this, we now find that the gradient, all right, of a line which is perpendicular to the line. So now gradient of a perpendicular line, so gradient of perpendicular line, all right, is defined as the gradient of a perpendicular line is defined m as m2 is equals to the inverse of the original line. Okay, the inverse of the gradient of the original line. All right, the inverse of the gradient of the original line, which is m1. All right, so in this case we know that m1 is equal to m1 here is already equal to this is m1 is equal to minus 3 over 2. So this is going to become minus 1 divided by minus 3 over 2. Right, so if you do that, you're going to get that this is going to be reversed. So this is the inverse, which is 2 over 3. So inverse of minus cancels out, all right, and then so you see the inverse of 3 over 2 equals to 2 over 3. So this is the answer to this question. So the gradient of the perpendicular line is always, remember, is always equals to the negative reciprocal of the gradient of the original line of the straight line. So this is the answer to this question. You can pause the video and remember to let's move on to the next question. In the next question, we have here, what is the locus point that is equidistant from point 1,3 and point 3,5? Right, so then to find the locus point equidistant to this distance. So now let's quickly draw a line here. All right, so we have this. Let's assume that this happens to be, so what we're looking for, so we're looking for this equidistance point. All right, first of all, so remember that this is point P. I'm going to call this point P. This is going to be my point P, which is going to be my coordinate for point P is going to be 1 comma 3, and then I'm going to say that these points become my point Q on the same line. All right, remember, on the same line. So I have Q here, and point Q is with the coordinate, Q is with the coordinate 3 and 5. All right, so what I'm quickly going to do here is to first of all find the midpoint. I'm going to use the equation of midpoint, all right, to find this equation. So equation of midpoint, right, midpoint, so midpoint is gotten at, midpoint is given as x1 plus x2 all over 2 comma y1 plus y2 divided by 2. So if we go ahead with this is going to give us, remember that from this equation, that this is x1, this is y1, this is x2, and this is y2. So if we go with that, x1 is 1 plus x2 is 3 divided by 2 comma y1 is 3 plus y2 is 5 divided by 2. So if we do this, this is going to give us, 4 divided by 2, that's 2 comma, this is going to give us 8, so this is 2 comma 4. All right, so this is the midpoint. So midpoint is at 2 comma 4. So this point is going to be the midpoint, which is now going to become, let's call this midpoint point R, and this point is going to become 2 comma 4. All right, now we've gotten a midpoint. We need to move ahead to find the so what we've gotten this, we need to find the slope, all right, of the slope of this point. Now, so the slope of this equation, so slope is going to give us, y2 minus y1 over x2 minus x1. This is going to be equal to slope m. So if we go with that, to m is equal to y2, you can see that y2 is 5 minus y1 is 3 divided by x2 is 3 minus x1 is 1. So you can see that. So this is going to give us 2 over 2, which is equal to 1. So this is equal to 1. Now next we find, the perpendicular gradient, right? So perpendicular gradient, remember that perpendicular gradient is given as m1 times m2 must be equals to -1. All right, perpendicular gradient, okay, m1 times m2 is equals to -1. Now where the perpendicular gradient is m2, right? So where the perpendicular gradient is that of m2. So if we make m2 such formula, m2 will become -1 divided by m1. Okay, now -1 divided, what's the m1? The gradient that we've gotten already, which is our slope, all right, which is 1. All right, this is our slope, which is m. So this is going to become 1. So -1 divided by 1, that's going to give us -1. With this, we've gotten the slope of the straight line, we've gotten the midpoint, we've got the perpendicular gradient. Next, we need to find the, all right, the point to line slope, so that we'll need to find next. Now we need to find the point to line slope. So next we're going to find the point to line slope. Now that equation is given as, so at that point is going to be the midpoint. So that is going to be, remember this point is point R, which you got to be 2,4. So we're going to find the point to the midpoint point. So that's going to give us y minus y1 is equals to m into x minus x1. All right, so this is what we need to get to find the equation. All right, so don't forget this is getting at point 2,4. So this is x and this is point x1, this is point y1. So if we do that, it's going to give us y minus our y1 is 4 is equals to m. Remember, we got our m as slope, m2 to be equals to -1. All right, so this is going to become -1 into x minus our x1 is 2. So if we do this, this is going to give us y minus 4 is equals to minus x plus 2. Okay, so making y substitute the formula, we're going to have that y is equals to minus x plus 2. Move this over here, this is going to become plus 4. All right, so this is going to become y is equal to minus x, and this is plus 6. So this is the equation. So the question that we've been looking for. Remember, the question asked us, we asked to find what is the locus of the point that is equidistant from the point this. So this is the locus. All right, now y is equals to minus x plus c. All right, minus x plus 6. So that's the answer to this question is option A, which is the correct answer to this question. Now we'll move over to the next question. Right, now in the next question, don't forget to subscribe to this channel if you're just joining us new. This is Daniel Maths Academy, and then follow us on our YouTube channel and subscribe. Hit the subscription button and drop a comment be in the comment section. Find the distance between point 1/2, 1/2, and this. So distance between 2 points is given. So this is this equation. This topic is coming from the equation distance between 2 points. So distance between 2 points is given as d is equals to the square root of, genus, we have that to be x2 minus x1 all square plus y2 minus y1 all square. So this is the distance between 2 points. So if we plug that in and then we write out the equation, right, so that's going to give us what? Remember that from here we have that we have the distance to be 1/2 comma 1/2 and point minus 1/2 and 1 minus 1/2. So you can see from here that this is our x1, this is our y1, this is our x2, and this is our y2. Right? So we'll go ahead to plug that formula. This is going to give us that d is equal to, so we're going to plug that in. This is going to give us x2 is minus 1/2 minus x1 is 1/2 whole square plus y2 is minus 1/2 minus y1 is 1/2 all squared. All right, so d is equals to square root the square root of minus 1/2 minus 1/2. All right, so what is this going to give us? Right, so this is going to give us, so minus 1 over 2 minus 1 over 2. So this is going to give us, and we'll solve this from here, right? So this is going to give us a minus 1. So how do we get that? To this, look at it, minus 1 over 2 minus 1 over 2. LCM is 2. 2 into 2 is 1. 1 times minus 1 is minus 1. Then minus 2 into 2 is 1. 1 times 1 is 1. So minus 1 is equals to minus 2 divided by 2. This is going to give us minus 1. So the answer to this question here is minus 1 square. Then here we'll have plus, and then if we do the same thing, we're going to get minus 1 all squared. So that's what we'll have there. So we can get rid of this. Now proceed from here. This is going to give us d is equals to square root. It's going to give us d is equals to square root of minus 1 square is going to give us 1, plus minus 1 square is going to give us 1. So that's going to give us d is equal to square root of 1 plus 1 is 2. So the answer to that question is that the answer is option D, which is square root of 1 over 2. And finally, okay, let's look at this question now. Find the gradient of the line passing through the point. Find the gradient of the line passing through the point. Now, gradient of line, remember that gradient of line M, gradient of line M is given as y2 minus y1 divided by x2 minus x1. Okay, now this is going to be divided by x2 minus x1, x2 minus x1. So we solve that. Consider that point P1 comma 1 and Q 2 comma 5. So this is x1, this is y1, this is x2, this is y2. So if we do that, we're going to have that m is equal to y2 is 5 minus and y1 is 1, and this is going to be divided by x2 is 2 minus x1 is 1. So m is going to give us 4 divided by 1. Therefore, m is equals to 4. So the slope of the equation passing to the point 1 comma 1 and 2 comma 5 is given as the answer option D. Alright, so remember, I can pause the video and watch again and again. So we're going to stop here for today, and then we're going to continue on tomorrow. So don't fail to look up to tomorrow's as we post, as we come up with a new exciting solve problems from JAMB past questions. All right, on JAMB 2026, as we prepare for JAMB 2026, we'll be looking at Thursday Maths, okay, with Daniel Maths Academy. Don't forget to drop a comment in the comment section, like our video, and then share this to people that will need this video. See you on Thursday Maths with Daniel Maths Academy.